Welcome to the deep dive. If you've been keeping an eye on tech news lately, AI, especially with these large language models, is just moving incredibly fast.
Breakneck speed, really.
Yeah, it feels like we're right at the start of a totally new way software gets built, how we even interact with computers. It's not just clicking buttons anymore.
Mhm.
Applications are starting to, well, understand, maybe even reason, and, act in the world for us.
It's a big shift.
So today we're doing our thing, taking a deep look at a really comprehensive report about navigating all this and pulling out the most crucial bits for you.
Right.
Our mission is to unpack what it really takes to build these sophisticated AI services that go way beyond just a simple chatbot interface. We'll get into the whole
Yeah,
ecosystem.
not just the LLMs themselves, right.
Exactly. The frameworks, the crucial techniques like RA to make them reliable, the potential of AI agents, and importantly, how to actually build this stuff correctly.
And it's definitely more involved than just, hitting an API. This report makes it super clear. LLMs are the core engine, sure, the intelligence part,
Hmm.
but the real power, the reliability, the stuff that actually works in the real world, that comes from how you integrate and orchestrate everything around them.
Right.
Going from a basic demo to a production-ready AI service means understanding this whole stack of tech and practices.
Mhm.
So this deep dive is really designed to pull out those essential, actionable insights from the report for you.
To help navigate this complex space.
Exactly. Complex, but also, incredibly exciting.
Yeah.
The foundation, large language models, LLMs.
All right, let's jump right in. The foundation, large language models, LLMs. These are the engines driving so much of this. Can
Yeah.
you give us the quick backstory? What exactly are these things?
Sure. So the idea of machines understanding language, NLP, natural language processing, it's been around for ages,
Yeah.
decades really, even before Turing.
Right, not brand new.
No, not at all. We had like rule-based systems, statistical models, early neural nets. But the report really pinpoints a key moment, the transformer architecture. That came out of Google around 2017.
Ah, the Transformer paper. Heard a lot about that.
Exactly. And it wasn't maybe until, say, post 2018, when people started really scaling it up,
Hmm.
that we saw this explosion of what we now call LLMs.
So what was so special about the Transformer, that self-attention thing it does? How did that change the game?
Great question. Before transformers, models mostly processed text, like word by word in sequence,
Okay.
which made it hard to connect words far apart in a sentence or across paragraphs. You lose long-range context.
Right.
Self-attention basically lets the model look at all the words in the input at the same time and figure out how relevant each word is to every other word, no matter how far apart.
Ah, like weighing the importance of everything simultaneously.
Precisely. It creates a much richer understanding of the context. And that ability was absolutely fundamental to scaling these models up to the massive sizes and capabilities we see now.
Okay, so the architecture is key. Then how do they actually learn? They're trained on just insane amounts of data, right?
Insane amounts is right. Usually there's this huge pre-training phase. They feed the model trillions of words, code, stuff scraped from the internet, books, you name it.
Wow.
And the basic task is often simple, like predicting the next word in a sentence or filling in blanks. But doing that at such a massive scale forces the model to learn grammar, facts, reasoning, different writing styles, all implicitly.
Just from predicting words.
Yeah, essentially. Under the hood, words get turned into these numerical vectors embeddings. Similar words end up closer together in this high-dimensional space.
Okay.
These embeddings go through many layers of the transformer network, getting refined, allowing the model to generate coherent, relevant text.
And that combo transformer, massive data, huge compute that led to these emergent abilities people talk about.
Exactly. That's one of the really fascinating parts the report covers. Suddenly, at a certain scale, models started doing things they weren't explicitly trained for.
Like,
Complex reasoning, writing code, summarizing really well, almost like they crossed some threshold. But, and this is crucial, the report stresses this, they are not perfect.
right.
They have serious limitations you absolutely have to deal with if you want reliable systems.
Okay, so what are the big limitations? What stops them from being, perfect oracles?
Well, several big ones. Practically, training and running them is incredibly expensive. Needs massive hardware.
Mm-hmm.
There's bias. They're trained on internet data, which reflects human biases.
Yeah.
So the models can learn and even amplify those biases. Unfair outputs, discrimination, that kind of thing.
Right, that's a major concern.
Definitely.
Yeah.
But maybe the biggest hurdle for building factual applications is what they call hallucinations.
Ah, yes, the infamous hallucinations, where they just make stuff up.
Precisely. They sound totally confident, but the information is just plain wrong,
Yeah.
fabricated.
Why do they do that?
Well, fundamentally, they're predicting the next most likely word. They don't know facts like we do. Ask them about something niche, or after their training data cut off, or sometimes just based on the prompt, and they can generate plausible-sounding nonsense.
Yeah, that's obviously a huge problem for anything needing accuracy. Medical advice, legal summaries.
Exactly. It's a major barrier.
So powerful but flawed. How do people try to fix this? Make them more reliable, more aligned with what we actually want them to do?
The report goes into techniques for this. RLHF reinforcement learning from human feedback is a big one, especially for making models more helpful, honest, and harmless.
How does RLHF work?
It's a multi-stage thing. First, humans rank different model outputs for the same prompt, like this answer is better than that one.
Okay.
Then, they train a separate reward model to predict those human preferences.
Ah, a model to judge the other model's output.
Kind of, yeah. Finally, they fine-tune the original LLM using reinforcement learning, basically rewarding it for generating answers that the reward model predicts humans would like. It steers the LLM's behavior.
Interesting. And there are other methods too.
Yeah, instruction fine-tuning is another key one. Training the model specifically on lots of examples of instructions and good responses helps it follow directions better.
So understanding all this foundational stuff, the architecture, the training, the flaws like hallucinations, the fixes like RLHF, why is that so important for someone listening who just wants to build an application?
Because the LLM isn't a magic box. Its capabilities, its limitations are fundamental constraints you have to design around.
Right.
Knowing it can hallucinate, knowing it has a knowledge cutoff, knowing it's probabilistic, it means you can't just blindly trust a single API call for anything critical. You have to build systems around it.
Systems to manage its behavior, check its facts, mitigate bias.
Exactly. You need structure, orchestration, ways to connect it to reliable information, which leads us nicely into the next topic, frameworks.
Because building those systems around the LLM requires more than just the model itself.
Absolutely. You need tools to manage that complexity and add capabilities. 2, orchestrating LLM workflows with frameworks. Focus. LangChain.
Okay, so orchestrating these workflows, LLMs are the brains, but they need help interacting with the world, right? Accessing data, doing multiple steps. Frameworks pop up here, and LangChain seems to be everywhere. What's the core idea behind LangChain?
Yeah, LangChain is definitely one of the most prominent open source frameworks for building LLM apps, Python, JavaScript versions available. The core philosophy is really about modularity and composition.
Modularity.
Yeah, breaking things down into reusable pieces. LangChain gives you a toolkit to connect different capabilities together, with the LLM often as the central reasoning piece. The main idea is building chain sequences of steps or operations.
Chains and links, hence the name.
Okay.
Okay. The report details some key components. Can you walk us through the important ones?
Sure. LangChain offers a bunch of abstractions. First, the LLM interface. This is super useful. Instead of writing separate code for OpenAI, then Google, then Anthropic, you use LangChain's standard interface.
Ah, so you can swap models easily.
Exactly. Makes you flexible, avoids getting locked into one provider early on. Huge benefit.
Makes sense. What else?
Prompt templates. Getting good results depends a lot on how you ask the LLM prompt engineering. Templates let you create reusable, structured prompts with placeholders.
Like filling in the blanks.
Yeah. Translate this text into language.
Yeah.
You fill in text and language. Keeps things consistent, easier to manage complex prompts.
Okay.
Then chains, the basic building block. An LLM chain just sends a formatted prompt to an LLM, but you can link them. Summarize text, then extract keywords from the summary, then format the output. That's a chain. They introduced LCEL, LangChain Expression Language, which is like a slicker way to build these chains in code.
Got it. Chains connect steps.
All right, and then indexes and retrievers. Absolutely critical for connecting LLMs to external data. This is the heart of RAG, which we'll get into more detail on soon.
Or a Retrieval-Augmented Generation.
Okay. LangChain has components for loading data, document loaders, splitting it into chunks, text splitters, turning chunks into vectors, embedding models, storing vectors in vector stores like Chroma or AI's, and then finding the relevant chunks for a query, retrievers. The whole RAG pipeline is built in.
That sounds powerful for knowledge-based apps.
It is. Then you have agents. This is where the LLM becomes more of a decision maker.
How so?
The agent uses the LLM to figure out what to do next to reach a goal. It gets access to tools like a web search, calculator, database access, APIs.
So the LLM decides, I need to search the web now.
Exactly. It plans, picks a tool, uses it, sees the result, and then plans the next step. It's an iterative loop.
Okay, more autonomous.
Yeah. And for conversations, you need memory. LLMs don't remember past turns by default. LangChain provides memory components to store history and add it back into the prompt for context.
Crucial for chatbots.
Definitely. And finally, callbacks. These are hooks to let you monitor, log, or debug what's happening inside your chains and agents step by step.
Wow, that covers a lot. Seems like a very complete toolkit. But the report also mentions LangChain gets some criticism. What are the downsides people point out?
Yeah, it's not without its critics. One common thing is complexity. All those abstractions can be, well, a lot to learn. Debugging a complex chain that goes through multiple layers can be tricky.
I can imagine.
Another point is hidden prompts. Sometimes the framework might add instructions to the prompt behind the scenes, which can make it harder to fine-tune the LLM's behavior if you don't know exactly what's being sent.
Less control.
Potentially. And because the field moves so fast, the framework itself evolves rapidly. That can mean breaking changes between versions, or some features might feel a bit underdeveloped. It's often that classic trade-off, framework convenience versus granular custom control.
Makes sense. High-level frameworks often have that trade-off, but clearly the upsides must be compelling for it to be so popular. What makes it a good starting point for many?
Oh, absolutely. The advantages are significant. Rapid prototyping is probably the biggest one. You can slap together a working app using these pre-built components really quickly.
Get something running fast.
Yeah. The modularity is great. Swap vector stores, embedding models, even the main LLM without major rewrites. It has wide integrations with tons of databases, APIs, services. It's a genuinely rich toolkit. And the community is huge, so there's lots of help examples, tutorials out there.
So great for getting started, experimenting, connecting lots of different things.
Exactly. Especially if you need that broad interoperability. It's often the quickest path from idea to working system.
And you mentioned one of its key strengths, connecting to external data, leads us right into RAG.
Absolutely. RAG is probably the single most important pattern that frameworks like LangChain really enable and popularize.
Right.
3. Grounding LLMs, Retrieval-Augmented Generation, are
Okay, let's really dig into RAG Retrieval-Augmented Generation. This term is everywhere. What is it fundamentally, and what big problem with LLMs does it solve?
So our RAG tackles those core LLM limitations we talked about. They don't know things after their training date, they can't access private info, and they hallucinate.
Right, the big three problems.
Our RAG solves this by grounding the LLM, giving it access to external authoritative knowledge right before it generates an answer. Instead of just relying on its training data, you fetch relevant info first.
So it's like giving the LLM cheat sheets for the specific question.
No, that's actually a pretty good analogy.
Yeah.
You augment the prompt with relevant context retrieved from a trusted source. It makes the output way more accurate, relevant, and trustworthy.
How does it work in practice? The report lays out a workflow.
Yeah, there's a pretty standard process. It starts with external data preparation, building your knowledge library.
Okay.
First, data ingestion. You gather your documents, articles, database info, whatever your source of truth is. PDFs, web pages, internal docs.
You get all the raw material.
Right. Then chunking. You can't just feed a whole 100-page PDF into the system at once. You split documents into smaller, manageable chunk. Finding the right chunk size is important.
Not too big, not too small.
Exactly. Then embedding. Each text chunk goes through an embedding model, another neural network, which turns it into a numerical vector.
The vector representation.
Yep. And the key is, chunks with similar meanings get vectors that are close together mathematically in this high-dimensional space.
Okay.
Finally, vector storage. These embedding vectors, plus the original text chunks and maybe some metadata like the source file, get stored in a specialized vector database. Figs AISS, Chroma, Pinecone, Weaviate, there are lots now. These databases are optimized for super fast similarity search. That's your searchable RAG library.
Got it. So that's the setup. Ingest, chunk, embed, store. What happens when I ask a question?
That's the retrieval phase. Your query, your question gets turned into an embedding vector using the same embedding model.
Same model. Crucial.
Yeah. Crucial. Then the system searches the vector database to find the stored chunks whose vectors are most similar, most mathematically close to your query vector.
Finding the relevant cheat sheets.
Exactly. Those retrieved chunks are the most likely pieces of external knowledge needed to answer your question.
And then those chunks get fed to the LLM.
Yep, that's augmentation and generation. The system takes your original query and dynamically inserts the retrieved text chunks into the prompt it sends to the main LLM.
Ah, so the prompt becomes like, Here's some info, retrieved chunks, now answer this. My question.
Pretty much, yeah. The LM now has specific relevant context right there in its input. It uses that provided context plus its general training to generate a much more grounded, factual answer. It prioritizes the stuff you just gave it.
And presumably you need to keep that external data up to date.
Absolutely. That's the ongoing part, updating external data. If your source documents change, you need to re-index them, re-ingest, chunk, embed, update the vector store. Otherwise, your RAG system gives outdated answers.
The report seems really high on RAG. What are the big benefits that make it such a big deal?
Oh, the benefits are huge, especially for businesses or specific domains. Number one, improved accuracy, fewer hallucinations, big time. Forcing the LLM to use provided facts drastically cuts down on made-up stuff.
Makes sense.
You get access to current info. You overcome the LLM's knowledge cutoff by updating your RAG data. You can use domain-specific knowledge, train it on your internal company docs, product manuals, whatever.
Crucial for internal tools.
Definitely. It's often more cost-effective than constantly fine-tuning a giant LLM with new facts. It offers transparency and verifiability. You can often show the user which documents the answer came from.
Oh, that's huge for trust. Citations.
Exactly. And it gives developers greater control over the information the AI uses.
So for anyone listening, if you need your AI to answer questions based on your specific documents, internal knowledge, recent events, RAG is basically mandatory.
It's pretty much essential, yeah. The report frames it as a fundamental architectural shift, moving from just generative models to systems that retrieve information and reason over it. It's a cornerstone for building reliable AI you can actually trust.
Okay, RAG grounds the LLM in knowledge, but what about systems that need to do things? Use tools, make decisions, act in the world. That leads us to agentic AI.
Right. That's the next evolutioning capability, 5 towards autonomous AI agentic systems.
Let's shift gears to agentic AI. This sounds like a leap beyond just generating text. What does it actually mean for an LLM to be an agent?
Yeah, it's a different concept. Agentic AI means using the LLM as the brain, but within a larger system that can actually plan, make decisions, and crucially, take actions to achieve a goal.
Taking actions, like what?
Like interacting with digital environments,
Yeah.
websites, databases, APIs, maybe even physical robots eventually. They use tools to extend what they can do. It's about moving towards AI that can actively solve problems, not just talk about them.
So you build this whole operational loop around the LLM. What are the key parts of an agent system, according to the report?
Exactly. It's a sense-think-act loop.
Yeah.
The report breaks it down. You obviously still have the LLM backbone. That's the core intelligence, the language understanding, the reasoning engine.
Brain.
The brain. Then there's a planning and reasoning engine. The LLM figures out how to break down a big goal, like plan my trip, into smaller steps. Find flights, find hotels, check weather, etc. Techniques like chain of thought prompting help here.
Thinking step by step.
Right. A key differentiator is tool integration. Agents get access to tools APIs for search, databases, calculators, email, calendars, custom functions. The agent's planner decides which tool to use and when. LangChain and others offer lots of tool integrations.
Giving the agent hands and senses.
Kind of, yeah. They also need memory to track the task, what steps they've taken, tool results, conversation history, short-term for the current task, maybe long-term for learning.
Remembering what it's doing.
Essential. Then, observation and reflection. After using a tool, the agent observes the result. Did it work? Did it get closer to the goal? Does the plan need changing? This feedback loop is critical for adapting.
Learning from actions.
Exactly. And finally, an agent orchestration layer manages the whole flow, when to think, when to act, updating memory, coordinating all the pieces.
It's quite a system. And the report mentioned different setups, single agent versus multiple agents.
Yeah. You can have a single agent system where one LLM orchestrates everything, but a really active area highlighted in the report is multi-agent systems, MAS.
MAS.
Yeah, multiple agents collaborating. Maybe one specializes in search, another in planning, another interacts with the user. They work together like a human team. This is seen as key for tackling really complex problems.
Can you give a concrete example? That trip planning one?
Yeah, that's a good one. Say you plan a 5-day Rome trip. A single agent might use a flight tool, then a hotel tool, then a weather tool, then build an itinerary, maybe email it using an email tool.
Okay.
A multi-agent system might have a dedicated travel search agent, a logistics agent, a weather agent, coordinating to build the plan. Platforms like Google's ADK, which we'll get to, are designed to help build these.
That sounds incredibly powerful, automating really complex stuff. But it also sounds way more complicated and maybe risky. What are the new challenges agents introduce?
Oh, absolutely. The report is clear on the hurdles. Complexity management is huge. Coordinating the LLM, tools, memory, observation, especially in MAS, gets very complex very fast.
Debugging must be fun.
Haha.
Yeah.
Yeah. Reliability and robustness are critical. How does an agent handle tool errors, ambiguous instructions, unexpected situations? Needs to be robust.
And security, if it's taking actions.
Big concern. Security. New attack vectors open up. Indirect prompt injection. Tricking an agent through data it fetches from a tool.
Oh.
Big risk.
Wow.
Cost can balloon. Complex tasks might mean tons of LLM calls, tool usage, and ethical considerations get way more serious. Accountability if an agent messes up, preventing unintended consequences, ensuring human control. These are tough questions.
So huge potential, but significant hurdles. Why is this move towards agents seen as so fundamental then?
Because it changes what AI can do, from passive generation to active problem solving. The path the report lays out, LLM Foundation, RAG for knowledge, agents for action, that's the trajectory towards AI that can tackle really sophisticated real-world tasks. It unlocks automation and collaboration potential.
And if these agents are going to act in the world, interact with tools, maybe even talk to each other, they need common languages, common ways to connect, which brings us to interoperability.
Exactly. Standardization becomes critical as the ecosystem gets more complex and diverse. Enabling interoperability.
Right.
MCP and A2A.
Right. The AI world is exploding with different models, tools, data. Fragmentation is a real risk. The report stresses that for agents, especially multi-agent systems, to really take off, we need standardization. Let's talk about the first protocol mentioned, MCP, the Model Context Protocol.
Yeah, MCP is a really important open standard initiative, championed by Anthropic initially, but seeing broad pickup. Its goal is to standardize how AI models, LLMs, agents integrate with and get data from external systems and tools.
Standardize the connection.
Exactly. The report calls it the USB-C of AI apps, which is a pretty good analogy. It aims to be a universal connector.
Okay, USB-C for AI. What problem did it solve? Why was this needed?
Before MCP, connecting an AI model to, say, your local files or your company's CRM or a specific API meant writing custom code for every single combination. Model A to tool X, Model B to tool X, Model A to tool Y.
The NNM problem.
Nightmare.
Okay.
Coder nightmare. Inefficient, locks you in. MCP provides a standard interface. Systems expose data or functions via MCP servers. AI models act as MCP clients to request data or trigger actions in a structured, model-agnostic way.
So any MCP app can talk to any MCP data source.
That's the goal. Makes things much more plug and play.
What are some examples of what MCP enables? Use cases.
The report lists several good ones. Desktop assistants, securely accessing your local files. Enterprise assistants connecting to internal databases or business systems safely. Multi-tool agents juggling various APIs. Software dev assistants, getting context from your IDE. Natural language database access. It's foundational.
And it's getting traction.
Yeah, major players like OpenAI, Google DeepMind for Gemini are adopting it. SDKs and servers are appearing for things like Google Drive, Slack, GitHub. Google's ADK framework supports it natively. It's becoming a key piece of the infrastructure.
Okay, so MCP handles AI to tool or AI to data communication. What about AI to AI? Agent to agent. That's A2A.
Exactly. If MCP connects agents to their environment, A2A, or agent to agent, aims to standardize how agents communicate with each other.
Ah, the Agent Social Network Protocol.
Sort of. It's another open initiative led by Google with many partners. It's critical for enabling those multi-agent systems we talked about. How do agents built by different teams using different frameworks actually collaborate? A2A wants to be that standard API for agent comms, avoids vendor lock-in at the agent level.
What does A2A need to define? What are its goals?
Key things include capability, publishing how agents advertise what they can do, interaction negotiation, agreeing on how to talk, text, forms, streaming data, secure collaboration authentication, authorization between agents, and framework agnosticism, making sure an ADK agent can talk to a LangChain agent or a crew.ai agent.
So message formats, timing, security, error handling, all that stuff for reliable communication.
Exactly. It's trying to build the robust communication layer needed for complex MAS.
Google seems pretty invested in this whole agent and interoperability space. The report mentions their specific offering.
Yeah, Google's playing a significant role. Two main things highlighted. The Google Agent Development Kit, ADK, and the Vertex AI Agent Engine.
Okay, ADK first. What is that?
ADK is their open source framework, mostly Python, for building agents and multi-agent systems. It focuses on giving developers precise control over planning, memory, tool use. It has some neat features like built-in audio-video streaming support for more natural interaction and an agent garden with examples.
Is it compatible with other frameworks?
They emphasize its compatibility, yeah.
Yeah.
It works alongside LangChain, LangGraph, Crew.ai, and supports MCP for tool integration. You can build locally or deploy to the cloud.
And the Vertex AI agent engine, that sounds like the cloud deployment part.
Exactly. That's Google Cloud's managed service for running your agents in production. It handles the infrastructure scaling, reliability, security, monitoring, all integrated with Google Cloud services.
Does it only run 80K agents?
No, and that's key. It's designed to support agents built with 80K, but also LangChain, LangGraph, Lambda Index, even custom-built agents. It helps with RAG integration using Google Cloud databases and manages agent memory.
So Google's strategy is like foster the open ecosystem with MCP and A2A, but also offer their own powerful integrated tools for building and running agents.
That's exactly the picture. Contribute to open standards for broad interoperability while providing a comprehensive enterprise suite. You can build an 80K agent connected to tools via MCP, have it talk to a LangChain agent via A2A, and run it all reliably on Vertex AI Agent Engine. That's the vision.
For someone listening, why does this interoperability push matter so much?
It means you're not trapped. You can pick the best tool for each part of your job. Maybe Llama Index for RAG, 80K for a specific agent role, connecting via open standards. It makes integrating different components easier, connects you to more data sources, and lets you build more complex, flexible systems without being tied to one vendor's stack. It's about freedom and composability.
Okay, we've got the models, the frameworks, RAG, agents, and the standards to connect them. Now, how do you actually put this all together into something that works reliably in the real world, that needs good architecture and solid operations, LLMOps?
Precisely. That's where the engineering discipline really comes in. Building best-in-class services. Building best-in-class AI services. Architecture and operations.
Right. Understanding the pieces is one thing, but assembling them into a robust, scalable application is a whole other challenge. What architectural patterns are people using for these LLM and agent systems?
Architecture choice is critical, as the report really drives home. It impacts everything: scalability, maintainability, cost. Table 1 in the source lays out common patterns. Simplest is just a single LLM call. Send prompt, get text. Good for basic tasks, maybe prototypes, but very limited.
No external knowledge, no actions.
Right. Then the most common pattern for knowledge work.
LLM.
LLM plus retriever, RAG. Your indexing pipeline plus the RA chain. Perfect for Q&A over docs, support bots, gets you factual grounding.
The workhorse pattern.
Definitely. Add tools, you get a basic agent, LLM plus tools. LLM decides which tool to use: web search, calculator, extends capability, but tool reliability and planning are key challenges.
A step towards action.
Yep. The most complex is a full agentic system. LLM plus tools plus memory plus retriever. Combines everything for autonomous multi-step tasks, personalized assistance, complex problem solving, but high complexity, cost, security risks.
The full package, but hard to build right.
Very. And then traditional patterns apply too. Monolithic, easy start, bad scaling. Microservices, scalable, maintainable, but complex orchestration. Pipeline pattern sequences stages, modular, but needs management. Adapter pattern integrating with legacy systems.
And specific agent architectures?
Yeah, the single agent versus multi-agent systems, MAS. MAS uses collaborating specialists. Curie-Ogden frameworks focus here. Offers scalability, resilience, specialization, but introduces communication and coordination challenges.
So no one size fits all. You pick the architecture based on the job.
Absolutely. Match the complexity to the need. Don't over-engineer.
Okay, you picked your architecture, built your system. Now you need to run it reliably, securely, cost-effectively in production. That's LLMOps. What is it and why is it so different or maybe more critical for LLM systems?
LMNs adapts DevOps and MLOps specifically for LLMs. And yeah, it's arguably more critical because LLMs have unique challenges. Non-determinism, same input, different output sometimes. How do you test that reliably?
Cool.
Our quality depends entirely on your data quality and freshness that needs constant management. Prompts are like code now that need versioning, testing, and evaluating open-ended text generation quality is way harder than checking traditional ML metrics.
So it demands a whole new level of operational focus. What are the key parts of LLMOps according to the report?
The report breaks it down comprehensively, referencing Table 2. It starts right at the beginning with problem definition and planning. Clear goals, KPIs, risk assessment, including responsible AI checks up front.
Plan before you...
That's essential. Then data management and governance, especially for RAG. Reliable pipelines for ingest, clean, chunk, embed, versioning data, embeddings, metadata, security, privacy, PII handling. Data quality and freshness are paramount and ongoing.
Data is fuel for RAG.
Exactly. Development and prompt engineering involves managing the build process, iterating on prompts, maybe using prompt management tools, versioning prompts like code.
Treating prompts seriously.
Absolutely. Evaluation and testing. This is tough. Metrics for correctness, hallucination rates, relevance, toxicity. Benchmarking, crucially, human evaluation for nuance. Red teaming to find vulnerabilities.
Yeah.
And continuous evaluation in production.
You don't just test once.
Nope. Deployment and serving. Choosing infrastructure, handling scalability, tricky with agents making multiple calls, safe rollouts like A/B testing.
Getting it to users reliably.
Right. Monitoring observability. This is huge. Track latency, errors, but also output quality. Detect data drift, concept drift, log inputs, outputs, traces, carefully handling PII, alerting on quality drops. Specialized LLM observability tools are emerging here.
Washing the outputs constantly.
Critical. Security, input-output validation against prompt injection. Access control for users and agents. Data protection. Rate limiting. Model provenance. New threats need new defenses.
Security is paramount.
Always. Cost management. Optimize prompts for fewer tokens. Caching. Choosing the right model size. Efficient fine-tuning if needed. Cloud cost optimization. These things can get expensive fast if you're not careful.
Keep costs under control.
And finally, responsible AI. Integrated throughout. Addressing bias, fairness, transparency, like citing RPE sources, user feedback loops, accountability, building trust.
Wow. That is a comprehensive operational picture. It sounds like skipping LLMOps means your cool AI demo will likely fail badly in the real world.
Pretty much. The report makes it clear. LLMOps isn't optional for production. It's the difference between an experiment and a sustainable, trustworthy, best-in-class AI service. It requires ongoing commitment and rigor. Building the demo is easy. Building something real and reliable is hard work that needs this discipline. 7. The evolving ecosystem and future horizons.
We focused a lot on LangChain because it's so prominent, but the report emphasizes the ecosystem is much broader now. What are some key alternatives, and how do they differ?
That's a great point. LangChain was early and broad, but now we see more specialized players emerging, which is healthy. Table 3 in the source highlights some. Llama Index is a big one. Its core strength is really RAG. While LangChain does RAG, Llama Index is often seen as more data-centric, more focused, and optimized for the ingestion, indexing, and retrieval parts. It have Llama Hub for tons of data connectors, advanced indexing options. If your main goal is building a killer Q&A system over your data, Llama Index is definitely worth a close look.
More focused on the data side of RAG.
Exactly. Then there's Haystack from DeepSet. It's strong in production-ready semantic search and Q&A. Uses a pipeline architecture, offers advanced retrieval methods, often chosen for enterprise search where retrieval accuracy is top priority. Very modular.
Focused on search and retrieval quality.
Right. And the report mentions others too, briefly. Flowize AI for visual low-code development. AutoChain is a lighter-weight agent framework. Agent GPT for browser agents. And Crew AI and Microsoft's Autogen, which are specifically designed for orchestrating multi-agent collaboration.
So the landscape is diversifying, from general purpose to more specialized tools.
Precisely. LangChain paved the way. Now tools are specializing for R, search, visual building, multi-agent systems. Developers can choose the best fit for their specific task, leading to potentially more optimized solutions. More choice is good.
Looking ahead, what does the report see as the future direction for agentic AI? Where's this heading?
The vision described is pretty ambitious. Towards distributed intelligence, with capabilities spread across many agents. Dynamic agent communication, using protocols like A2A for fluid collaboration. Agents capable of autonomous adaptation and learning, maybe using multi-agent reinforcement learning. Highly specialized agent collaboration tackling huge problems. Even embodied AI controlling robots, and multimodal agents understanding text, images, audio, like Google's AMIE project for medical dialogues.
That sounds like science fiction becoming reality, building digital societies almost. What are the roadblocks? What needs to happen to get there?
The report is realistic about the major hurdles. Technical challenges. Managing the sheer complexity of potentially thousands of agents, scalable inference, robust communication, getting the right data.
Huge engineering problem.
Massive. Then security and stability. New attack vectors, ensuring systems remain predictable, dealing with emergent behaviors, the opacity of LLM reasoning, making debugging hard.
Keeping it safe and reliable.
Critical. And ethical and governance issues. Accountability when agents err. Preventing bias spread, privacy, human oversight. These are profound societal questions too. The report notes large-scale MAS in production are still rare, showing how early we are.
So huge potential benefits, but matched by equally huge challenges.
Absolutely. The potential to transform research, healthcare, automation is incredible, but realizing it needs breakthroughs in protocols, reasoning, planning, and new governance, ethics, security frameworks. Building trust is everything.
For someone listening, why is it important to track this evolving ecosystem and future vision?
Because understanding the current tool landscape helps you choose better today. And knowing where things are likely heading toward more sophisticated agents, multi-agent systems lets you anticipate, experiment incrementally, and be prepared to leverage those future capabilities when they mature. It's about staying informed in a field that's moving incredibly fast. 8. Key takeaways and recommendations.
Okay, what a journey. We've gone from the foundational LLMs through orchestration frameworks like LangChain, the absolute necessity of R, the potential and pitfalls of agents, the critical need for interoperability like MCP and A2A, and the operational backbone of LLMOps. Let's boil it down now. What are the core strategic recommendations from the report for navigating this?
The report offers some really clear, practical advice.
Embrace continuous learning. Stay updated. Models change, frameworks evolve. Flow as AI, Crew AI, Autogen pop-up. Techniques improve. Experiment. Hands-on is key.
Keep learning, always.
Second, start with clearly defined problems. Don't build complex agents for the sake of it. Find high-value use cases with clear inputs-outputs. Focus your effort.
Solve real problems.
Third, prioritize R for knowledge tasks. If you need factual answers from specific data, use R first. It's usually the best path for accuracy and relevance, often better than fine-tuning for knowledge alone.
RAG is king for knowledge.
Fourth, select tools judiciously. LangChain, Lemma Index, Haystack, ADK, others. Evaluate based on your needs, team skills, requirements. No single best tool. Mix and match using standards if needed.
Choose wisely.
Fifth, invest in LLMOps from the start. If it's going to production, build an evaluation, monitoring, security, data governance, cost management from day one. Don't wait.
LLMOps isn't an afterthought.
Sixth, explore agentic patterns incrementally. Start simple, LLM plus a tool, add memory, then maybe explore multi-agent systems as you learn. Don't dive into the deep end immediately.
Baby steps with agents.
Seventh, champion interoperability. Use and support open standards like MCP and A2A. It helps everyone, reduces lock-in, makes systems more flexible.
Or open standards.
And finally, eighth, embed responsible AI throughout. Ethics, fairness, transparency, accountability, security. Think about these constantly at every stage. Build trust.
Responsibility is key.
Yeah, the core messages. Building great AI services means using powerful models, smart tools, robust architectures, solid operations, and a deep commitment to doing it responsibly and openly. Create services that are intelligent, yes, but also robust, trustworthy, and genuinely beneficial. Outro. So yeah, quite the deep dive today. We covered the LLM foundations, frameworks like LangChain for putting them together, RIG for making them factual, the move towards agents and multi-agent systems, the standards like MCP and A2A needed to connect everything, and the crucial LLMOps for making it all work reliably. It's moving fast, but the key pieces are becoming clearer.
Right. And the big takeaways for you listening: keep learning. Start with clear problems. Use ORG for knowledge. Choose tools carefully. Do LLMOps early and seriously. Explore agents step by step. Back open standards and build responsibly, always. Now, here's something to chew on, picking up on that future vision the report touches on. This idea of creating societies of AI, multi-agent systems where specialized agents collaborate like human teams. What does that really look like at scale when different AIs, maybe from different companies, truly collaborate seamlessly? What new capabilities does that unlock for tackling problems we can't even imagine solving today? And crucially, what are the absolutely non-negotiable technical, security, and ethical guardrails we must build to ensure that future is not just powerful, but safe, reliable, and beneficial for everyone? It's a mind-bending future that needs careful, deliberate steps. Thank you so much for joining us on this deep dive into the AI agent stack. We hope exploring this report's insights gives you a better map for this incredibly exciting territory. Keep exploring, keep building, and keep learning.